Hi, how's it going? This episode, we are gonna talk about delta time, and it took me so much to stop myself from saying delta V from playing Kerbal Space Program so much. But this is so this is where we left off last time with our ship, and here we are. Here it is, just cruising around the screen at high speed, not so let's check out what kind of speed it has. So I've got it set to speed 1, which means it's going to move a single pixel every frame, which means it's going to move 60 pixels every second because we are running the game at 60 frames per second. So this is what 60 pixels per second looks like. Now, if we wanted to make it move faster, we could just increase this. Maybe we want to do 600 pixels per second, which looks like this, which seems like it's something, manageable. It's something we can deal with. But there's a problem. What if we didn't have the frame rate at 60 frames per second? What if we had the frame rate lower? What if we're running this game on a potato? We're running at 30 frames per second. Well, now it's even slower. So what do we do then? Do we just bump up the speed to 100 again? Oh, no, that's too fast. So then what do we want to do? Are we trying to find the sweet spot? So maybe we want to do 60. That's not necessarily the solution. Also, look at the blue dot. What is going on with that? I better know what that is, actually. It's probably the order in which we're doing stuff. Maybe this needs to be ahead. Let's just troubleshoot that now. Okay, yep, now it's sticking. But neither of these are the solution. We can't keep adjusting the speed versus the frame rate. Or can we? What if there was a way that we could figure out what the frame rate was and then make an adjustment to the speed? Well, there is exactly that, and it's called delta time. Let's go ahead and implement delta time. Here is an illustration of delta time. Now, there's two ways of doing this in Python or Pygame. You can calculate it on the ticks, which is actually integrated into Pygame, or you can add a module called time. The difference between the ticks and the time are the time frames in which they are represented. Delta time using time does that based upon seconds. And delta time using ticks uses milliseconds. And the difference of them is 1,000. So to get these two rectangles running at the same speed, I had to offset them by a factor of 1,000. Now, this rectangle at the bottom is running at speed 1. It's going 1 pixel per frame. And right now we're running at approximately about 100 frames a second. So it should be at the same speed as these, except it's not. It's varying. It's averaging less. So on average, it's going between what looks like 96 and I don't think it reaches 100. I think it's trying very hard. But so that would say it's running at a frame rate of about 97 as opposed to the rest of these, which are running at a constant speed. And those are being adjusted by delta time in two ways. Now, the reason that we want this is because if we were to slowly decrease the frame rate, you can see that one will start decreasing in speed as well, whereas the other two, no matter what, will still go across the screen at relatively the same rate. See how they're skipping now? For every time they skip, the distance that they have to skip, that rectangle on the bottom is not skipping at all. And now we have the same problem in the other direction. If we start increasing the frame rate to where we go above 100, which is the relative speed of those rectangles. Now we're going to get the lower rectangle start speeding up. And the extreme of this is when you have basically making it run at the maximum that it can, which looks like that. So that's the problem. That is why we need to implement DeltaTime. Now, implementing DeltaTime means you just have to do a calculation, and then you have to apply that calculation to the speed of everything that you're trying to move. Every object in your game that moves will have to have DeltaTime applied to it, which is the same as basically multiplying its velocity by the value of DeltaTime. So the way I did it was I defined a common point, because you're wanting to measure the time between 2 points. So you need to set a start, and then you need to set a current, and then you want to make the current time the start time again and repeat. So it's kind of like a ratchet system where like you move and then it holds, and then you move again and then it holds again. So let's set ourselves, it's not necessarily a constant. We can make another section here and call it variables. And then we want to call this something like last time. And then we want to set that equal to Pygame time get ticks. And that's a method. And so that will set the, from when the program starts running, Pygame is keeping track of how much time has elapsed in milliseconds. And what this does is it will set a time there. So we can, let me see how I can do this. Can I set, let's do, see, it's going to take an amount of time for it to get from last time to this. Let's go ahead and run this program here and set the breakpoint there. Oh, I got an error. Has no attribute get. Oh, ticks. Sorry. I'm gonna set this there, right? And so we're gonna do this, 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 and then this. And now last time it took us 2,600 and so about 3 seconds to get here because I was stepping through slowly. So yeah, this point is how quick it gets there, and then it just keeps that number. So then we got to go down to our game loop. And this is where we want to do the ratcheting system. We want to do this relatively close to the top. I prefer to do it before I do everything. Maybe after the clock tick, which is governing our frame rate. So while we're here, now we want to define our delta time, which we can just do as dt, seeing as we're going to be typing this a lot. And our delta time is going to be how many milliseconds it is now minus the amount of milliseconds it was before. We're going to do Pygame, again, time, get ticks, and then we're going to subtract last time. And then directly after that, we want to, because we have our value now, we have our delta time value. We want to then update last time again, use to Pygame get ticks. So now nothing's going to change. This is still acting the way it does because it's set to speed of 60. So let's set it to a speed of 1 again. We're at 30 frames per second. And it runs dog slow. The way we want to change this is when we don't want to change delta time here. This won't do anything. Actually, it's not going to work because I believe this is getting, yeah, this is the spaceship object is getting defined or getting created. Yeah, spaceship gets created here. Delta time is made here. So we don't want to apply delta time in the init section. We also don't want to do it there because it will never get updated. So the frame rate that it gets will be, well, I mean, it just never would happen anyway. But the frame rate that it gets at that time, it would keep. And so the ship would be jagged as it moves around the screen. Like it would be relatively close to the speed that you want it to be at, but it will still be jagged because the frame rate will be moving and it would not be updated. Now, the movement method is being called inside update, and update is being called constantly within the loop. So it's going to loop through update every time because that's how we designed it before. And update is going to call movement, and movement is saying if you press in the up key or W, you're going to want to decrement by the speed multiplied by delta time. So I'm going to apply delta time in the up-down direction, but I'm going to leave it in the left-right direction. So now we have the thing going, still going slow, but now we are going faster in this direction. So if we add, or times, I should say, delta time there, and also times delta time here, we should now have a ship that goes in all directions. Now note the speed in which it moves from left to right and up and down. It actually goes faster diagonally, but we can adjust that in a future video because going diagonal is actually the same as adding the horizontal and the vertical. So see, we're looking at a square. If we're moving left and right, we're moving what would be considered the distance at the base. And if we're moving up and down, we are moving the distance of the height. But if we move in diagonals, we are actually moving at a distance of the hypotenuse of the right triangle that goes from corner to corner, which is longer than both the height and the base. So we will implement like a direction kind of thing, and it will adjust to remove the difference the hypotenuse has from the length or the height. But now, here's where the magic happens. Let's change this to 60 frames per second, not 600, not yet anyway. So now, look, we are still moving at basically the same speed. But to take this at extremes, let's remove the frame rate cap. And see, now we're moving at what's looking like almost 2,000 frames per second. But look, we are still moving at the same rate. And that is why we use delta time.